In this section, we're really going to be using these exponential rules, these two exponential rules, and really getting to know them a lot more and how to use them. And this is honestly really helpful if you're going to get some of the more advanced math classes. So this first one, we're actually very familiar with both of these rules. So if you multiply numbers with the same base, what are you supposed to do to the exponents? Well, you add them. And if you have a power to a power, what do you do with those? You multiply them. Now, what are we going to do in this section is we're actually going to be doing these a lot going backwards. What if we are adding two exponents? Well, we can separate them out as two numbers where we're multiplying the same base. What do we do when we're multiplying the two numbers in the exponent? Well, we can separate them as an exponent to an exponent, and you're going to see that in the next few examples. So let's look at this first example. So we have 6 over 17 to the 9x. Well, we could rewrite that as 6, don't like those parentheses, 6 over 17. Well, think about that. That's 9 times x, right? So that's this rule right here. We have m times n. We have 9 times x. So let's try to rewrite it looking like that instead. So I'm going to have 6 over 17 to the 9, and then that would be to the x power. Think about that. We have a power to a power there. We'd have 9 times x, the power to a power. So what you could be thinking of is this as a to the x. So what would a be? Well, a would be 6 over 17 to the 9th power. Now you might be thinking, couldn't we have rewritten this instead like 6 over 17 to the x to the 9? Yeah, you could have, but this question wants us to write it in the form a to the x. This outside power is an x, so it wouldn't really quite take that form. So technically these are the same, but this wouldn't help us answer our question. Let's take a look at this one. This one they want us to figure out what a is, where a is times 3 to the x. So this looks really confusing. Honestly, it kind of is at first, but once you see it, it's not that bad. So what I'm going to do is I'm going to take a look at this one right here. And I'm going to take that one. If you remember, if you have, it's a to the m times a to the n. So if you have a to the m times a to the n, that would be a to the m plus n. So what I'm going to do is I'm going to separate these using that rule. So I'll have 3 to the x for this first 3 to the x that we see there. And then minus, this will be 3 to the x times 3 to the negative 2. Think about what happened there. This right here is the same thing. This, I'm just applying this rule, but backwards. 3 to the x times 3 to the negative 2. Well, what would we do if we're multiplying numbers of the same base? What would we do to the exponents? You would add them. So here you just see x minus 2, because we're going to add that. X plus negative 2 would be the same thing. And then these parentheses, I don't actually need them. Well, let me just write that in the next step. So we would have 3 to the x minus 3 to the x times 3 to the negative 2. And then what I'm going to do is I have the 3 to the x times and the 3 to x there. I can factor that out, leaving us with a 1 minus 3 to the negative 2. So here we have our 3 to the x. This is our 3 to the x. And here, this is a. So a is equivalent to 1 minus 3 to the negative 2. Now, Khan's not going to accept that as an answer. So you're going to have to do 1 minus 1 over 3 squared, which is 1 minus 1 over 9, which is really just 9 over 9 minus 1 over 9 to get 8 over 9. And they'll accept that as the answer.